All right, so welcome back. So in this lesson, I'm gonna go over I guess the relationships between angles, kind of parallel lines and triangles. It's a common topic all the way back to elementary school, but I know that it shows up in high school and in grade 9. Commonly, you would run into this. It's pretty neat to know the relationships between. I think if you're watching this, you should also kind of ask yourself, why it is true, okay, that all of these relationships hold, because I think that's kind of cool to understand. Most people typically just simply memorize the rules. So let's take a look through it. So I'm not going to try to make it too terminology based. I'm going to just try to give you what the relationships are. Now, when you're working with lines, or later as I'm going to scroll down, we're going to be working with triangles. Obviously, if you have two lines that cross each other, they do create some kind of an angle. And now we want to be able to work with all of these angles and the relationships between them. And all of this can actually be derived from the simple fact of knowing that if you have a straight line, then that particular straight line, okay, has an angle of 180 degrees. And now if you cross that straight line in any way, then any of the two angles that you may have, so for example, if this is angle A and then angle B, okay, so if we have that, okay, and this is our straight line right here, so let me just draw, so this is our straight line right here. So the addition of those two angles, A and B, is always going to be equal to 180 degrees. Now, if you take that, then you can derive pretty much everything that I'm going to talk about. All right, so let's take a look. So the first thing that you notice, if A and plus B is equal to 180 degrees, that means if you take the other straight line, which is this one going right here, that is telling you that this angle, okay, must be B, okay, because A plus B is equal to 180 degrees. And then again, this tells you that this must be A. And that's kind of one of the main key first relationships that we run into. So that these opposite angles, so this one and this one, are always the same when you cross, and this one is going to be the same as well. So that's kind of the first thing that you should remember. So those angles are identical. Now, if you take two lines, so again, I'm going to go back here to two lines and the kind of two parallel lines, okay, that we see right here. So these two lines are parallel. So they never meet. And then all of a sudden you try to cross those two lines with another one, as has been done here. You can create quite a lot of relationships in between. All right, okay, these particular angles by using some of these little tricks right there. All right, okay, so let's take a look at that. So one of the first items is, okay, so that you have is that if you have this interior angle right here, so let's call that angle A. Let me blow this up. All right, so this is what we would have there. Then you will find out that this angle, this interior angle on the opposite side right there, is also A. All right, so this is just from the parallel lines. And often what people do is, okay, so they kind of nicely will draw, I always kind of thought of this when I was in school as just as a Z, right? So if this is a Z or a Z, okay, so if you draw that in, those angles are going to be the same whenever you have two parallel lines. So that's something neat to know. There is a name for this. I actually don't really use the names, to be honest with you. I don't always remember them. Okay, so but I do remember that the Z, okay, pattern, those two angles are identical. Now, if you do the same thing with some of the other ones, okay, so what you have as we continue, you can make some other patterns. And another pattern that I do remember, so whenever you create a pattern of an F, so let's say if I had something like this, so this is an F right here, you will again notice that these angles, so this one and this one, are also the same All right, so that's something neat, okay, to remember. Okay, so those two angles are also the same, and that's kind of the F pattern. So we have a Z pattern, we have an F pattern, all right, and then those angles are actually the same, all right. So another pattern which is common, okay, so now based on those, so what we have here is that, okay, so if we have, let me highlight this for you here. So whenever you have a C pattern like this, all right, so as you create these, you may wonder, what is happening, okay, within the interior angles, okay, that you have. So these are C pattern angles. So for example, this one, okay, and this one right there. So you may wonder, are they the same? Okay, are they not the same, and so on. So this C pattern, they're not the same, but if you think about what we started with, that two angles, so for example, okay, if you kind of go back here and you use the F pattern, okay, so you will notice that this angle right here is B, because that's an inverse F, okay, that we would have. So you would have to draw the line and then the kind of F upside down. So these two angles would be the same that you see right there. Okay, and that means that the A and the B is equal to 180 degrees. So here we like to remember this, okay, as having a 180 degree when you sum them up, okay, in this C pattern that you run into. All right. Okay, so those are kind of the parallel lines, some connections in between. And again, I believe that you should have had this in elementary school. Okay, so in terms of trying to figure out, and then they'll bombard you with some examples so that you can kind of play with these, and you can create all kinds of lines. I think students it's good if you start just drawing lines all over the place and then trying to see which patterns actually work, and then which of these you can actually utilize. Now another item, okay, once you have these parallel lines, okay, then you can start talking about triangles, and then also use some of those methods of lines to construct triangles. So one of the probably most well-known, okay, within triangles and angles is if you do have a triangle. So notice that we have three vertices. So we have a vertex here, okay, at A, at B, and at C. So I'm referring to those small letters just simply as angles, okay, so that we have, so this is an angle right here, that's the angle right here, and then this is the angle right there. So you may remember, okay, that when you're adding up the angles, the sum is actually 180 degrees always. And I encourage you to try to see like where this comes from. I'm going to give you a hint. Because I remember when I was studying this, someone showed me this hint. I kind of remembered it, so it's not my hint. So the hint was, you can actually prove that A plus B plus C equals to 180 degrees if you use, okay, these parallel lines to your advantage. So for example, what you can do is, okay, so I'm going to borrow this line right here. Let me duplicate it. Okay, so here, let me duplicate. All right, and because it is now, so I'm going to put it right there. I'm going to stretch it out a little bit. All right, so if you would do that, then it makes these lines, so this line parallel to this line. And then with that little trick, okay, you can actually pretty easily, okay, find out that A plus B plus C is equal to 180 degrees by using, okay, just what we had right here. All right, so the Z pattern in particular, so notice it will tell you that this is B, okay, and it will tell you that this is C. All right, so, and then there you have it. So A plus B plus C has to be 180 degrees because a line, okay, has an angle of 180. Okay, so that's something that you can think about. Let me erase this back out. So that's one of the first rules for triangles. Now, the other concept sometimes is referring to kind of the exterior relationships between triangles. So when you have these angles, so the A, the B, and the C, those ones are typically called interior angles. So these are the interior angles of the triangle because they're on the inside. And then the exterior ones, so for example, this would be, I'm going to call this C prime, right? So you don't confuse it with C. Okay, and then I'm going to call this A prime, and then I'm going to call this one B prime. Okay, so for all of these, you will know, okay, that A plus, for example, A prime must be 180 degrees. So that should make sense to you. And then the same thing obviously happens to B plus B prime is equal to 180 degrees, and C plus C prime is equal to 180 degrees. This is all used, okay, just from these line properties that we had there. Okay, and what we call these particular angles, so this, okay, so this A prime in here, now of course you can call them, you can label them any way you like, okay, but these angles are called exterior angles. All right, so those are the exterior angles. And there are some actually nice relationships for exterior angles as well. So just as we have the interior angles to have a relationship, so A plus B plus C equals to 180 degrees, we also have a nice relationship between, so if we call this A prime, call this B prime and C prime. So it turns out, and I wonder if you know this one, okay, so the summation of these, it's not 180, but it is actually 360 degrees. Okay, so that's one of the relationships for exterior, okay, angles that we have of triangles. So that's a useful one to know. All right. Okay, now another relationship, okay, that we have. So if I input in here, so I'm going to input, so this was A and this was B, right, and this was C. If you know these two angles, so for instance, if I know, okay, so this angle A and then this angle B, I actually know something about this particular angle outside. All right, so there is a relationship which goes hand in hand. So the A plus B, okay, has something to do with the C prime. All right. Okay, so I'm going to let you think about that one, and then maybe someone can put it up in the comments, okay, because it's another useful one to know. So my question to you is, if you know A and if you know B, meaning if you know two of the interior angles, okay, what do you know about the exterior angle of the opposite one? All right, and you can kind of think about it from the viewpoint of that if you know A and B, then you obviously will know C. All right, so you will know that, which will tell you something about C prime. All right, so I'm curious, okay, if somebody can put up that exterior relationship, okay, for us in the comments. All right, so that I don't give it all away and it makes you think a little bit. All right, so now with this, okay, so as we know these particular items and relationships, we can certainly do quite a lot of examples. So for instance, okay, so if I give you some examples, I'm going to take this first one right here. And let's say if we know these, okay, so if I know this exterior angle and I know this interior angle, let me find out all the other angles. All right, so I want to find every single angle, every interior and exterior angle. Okay, and typically if you're going to go about that, so I mean, I know that if the exterior one is 160 that you see there, then it should make sense to you that this one is 20 degrees because 160 plus 20 is 180. So I know another interior angle. If I know, okay, the two interior angles, so notice I have 20 degrees and 70 degrees, then that tells me something about the other interior angle because the summation of them is equal to 180 degrees. So if that's true, so 180 minus 20 and then minus 70, okay, so that is equal to 90 degrees. So this one is 90 degrees because, as you can see, so 20 plus 90 is 110, plus 70 is 180, which is all the interior angles. And now, of course, okay, so notice, okay, so this one is also going to be 90 degrees. And this one right here, so the one by the 70 degrees, okay, so that one has to be 110 degrees. And that gives us all the angles that we have. All right, so that's a nice test just to kind of remember the relationships within the angles for interior and exterior angles of a triangle. All right. Okay, so here's another example. So this is not always used, but I mean, I like these a little bit better. So let's imagine that they give you, I'm going to take the one in pink. Okay, so first, so let me maybe copy this down. All right. Okay, and I'll bring it down here so that we can work on it. So let's imagine that we were asked, or we were told that the ratio of the exterior angles is 1 to 2 to 3. All right, so that's the ratio between them. And now, let's say I ask you, please find out all the angles that you have, if they're possible, of course. If this is the supposedly, okay, the relationship. So now this is the exterior angles. Now we don't actually know the sizes of them, right? But we know the ratio of them. So that is great to know. So we can use the unknowns. So for example, what I do is, okay, the first angle, because I don't know it, right? And then the ratio of that one is 1. So I'll call that x. Okay, so it's some angle x. And now notice it's going to be in a ratio of 2x, okay, because that's the 2 right there. Meaning the second exterior angle is going to be 2x, and then the third exterior angle is just 3x. And if I know x, then I basically know all the angles, right? Now, what do we know about exterior angles from what I just presented? Well, we know that the exterior angle, so x plus 2x plus 3x was equal to 360 degrees. So now we just solve for x. Right? So x plus 2x plus 3x is actually 6x. So this is 6x is equal to 360. So x, so dividing by 6, we're going to get 60 degrees. So that would tell me that x was 60 degrees. All right. That 2x is obviously 120 degrees. And 3x would be 180 degrees. And this is a problem because, so notice 180 degrees is basically just a flat line. So if you're talking about angles, that would tell you that that exterior angle, there would be no interior angle for the triangle, right? It would be just flat. So here we cannot solve, okay? So this is actually a relationship which tells us that this triangle does not exist. You cannot have a triangle with an exterior angle of 180 degrees. And I hope that makes sense to you because it's just a flat line. All right. So now we can do, let's see the other one. So here's another example. So a ratio, so let me copy this. So ratio of an interior. Okay, so let's put that down there. Okay, and this would give us the relationship for interior angles. So again, so I kind of use the trick because I don't know my actual true angles. I just know the ratio between them. Okay, so again, so what I'll do is, this is an orange. So I'm going to put x kind of at the end there. This is 2x and then 2x right here. So that's the ratio in between. So whatever angle is of this last one right here. Now it doesn't really matter the order, right? So these are my interior angles. Well, from interior angles, I know that the angles of the interior triangle is basically equal to 180 degrees. So I have 2x plus 2x plus x is equal to 180 degrees. So this is 5x, okay, equals to 180 degrees. All right, so now dividing, so we're going to divide by, in this case, 180 divided by our 5. Okay, it's just 36. All right, so this is 36. So that's x. And that would tell me, okay, so that 2x, okay, is equal to 72 degrees. Okay, so I would have 72 degrees to 72 degrees and to 36 degrees. And now the question is this possible in a triangle? Yes, of course. Okay, so all the angles are summing up to 180. And so basically this is a triangle with two of the same angles, and one is 36. Okay, and now you can find all the exterior angles if you wanted to, right? Okay, so for example, the exterior angle of this one, so the 36, okay, so that would be 180 minus 36. Okay, so 180 minus 30 is 150, and then minus 6 is 144. So that would be one of the exterior angles. And you can do the same thing for the 72, right? So 180 minus 72, I guess would be what, 108. Okay, so you would find all your exterior angles. All right, so that's the lesson, kind of the first lesson in relationships in between kind of angles. Okay, so we started off with triangles and lines, and in a future video we'll do maybe some other polygons. Okay, so we'll see you in a future video. Thank you for watching, and take care of yourself. Okay, bye everyone.